So what is a mass extinction? So basically the natural background rate of extinction for species across the board, just generally speaking, is around 10% of species are lost every 1 million years, around 30% every 10 million years, and about 65% every 100 million years. So just in general, mass extinction is defined as a period with much higher extinction rates than normal. At least 75% of species go extinct within a relatively short period of time, and this is by geological standards, so typically within less than 2 million years. So throughout geologic history, there's been 5 big mass extinctions. The first one was the Ordovician Silurian, which was around 444 million years ago. And this was back when most of life was underwater. So it was before the large animals had, invaded land and stuff. So here we had lost around 85% of species. And this was due to the uplifts of the Appalachian Mountains, which created lots of chemical weathering. The weathering was sequestering CO2 from the atmosphere. And since we know that CO2 is a powerful greenhouse gas, when CO2 leaves the atmosphere, it triggers global cooling. So this rapid global cooling triggered glaciation, which lowered sea levels and killed a lot of marine life, because of the shallow continental shelf. Ecosystems were destroyed. The next biggest mass extinction was the Lake Devonian. This was about 360 million years ago. Here we lost around 75% of species. This was the collapse of marine ecosystems, and it's thought to be caused by the rapid growth and diversification of land plants, which removed CO2 from the atmosphere and again resulted in rapid global cooling, because these plants are taking up a lot of CO2 from the atmosphere, which, as we know, is greenhouse gas. And once CO2 leaves the atmosphere, it makes the atmosphere trapping less heat and it causes global cooling. The third big mass extinction event is the Permian Triassic, around 250 million years ago. So this was the loss of around 96% of all species on Earth based on our fossil record evidence, and it's thought to be due to this intense volcanic activity in Siberia. So these volcanoes were spewing tons of CO2 and sulfur into the atmosphere, which caused global warming because there's more greenhouse gases in the atmosphere. And it also resulted in ocean acidification because more CO2 was dissolving into the ocean. And this was considered the largest extinction event of all time. And here we lost a lot of amphibians and synapsids. Then we had the Triassic Jurassic, which is around 200 million years ago. This was thought to be due to the eruption of the Central Atlantic Magmatic Province, which is associated with the break event Pangaea, and again released a large amount of CO2 and SO2. Which caused global warming. And this was thought to open up the ecological space for dinosaurs to dominate during the Jurassic. And then finally, we have the most famous of the big 5 mass extinction events, the Cretaceous Paleogene, also known as the Cretaceous Tertiary, which occurred 65 million years ago here at the Yucatan Peninsula in Mexico. And it's thought to be caused by this asteroid impact. And it's known as the Alvarez hypothesis because it was discovered by the scientist Alvarez. And the impact of this asteroid caused rapid global cooling due to large amounts of dust that was blasted into the atmosphere. So, all the dust in the atmosphere is blocking out the sun. And when less sun is getting into the atmosphere, it caused this rapid global cooling. And it was also linked to this volcanism, the Deccan Traps. So the Deccan Traps was this large igneous province in west central India, and it was releasing huge amounts of CO2 and SO2, and that caused global warming after the Alvarez hypothesis, after the impact of the Yucatan Peninsula asteroid. So these two in combination were thought to be what caused the extinction of the dinosaurs. So what do all of these 5 big mass extinction events have in common? And what's missing from this list? So the answer to that is that they all involve some sort of rapid climate and environmental change. So all mass extinction events seem to be caused by rapid climate and environmental change. A lot of them were caused by this volcanism, so lots of degassing of CO2 and SO2, causing rapid global warming due to more greenhouse gases warming the atmosphere. And then the asteroid impact causes severe global cooling. So the point is, species across the world find it really hard to respond to rapid changes in climate. So let's change gear a little bit and get into the Pleistocene extinction. So this isn't considered one of the big 5, but the Pleistocene is basically the era just before the current geologic age, during the time of cavemen and mastodons and woolly mammoths and saber-toothed tigers and stuff, just anything over 10,000 years ago. So between 10,000 and 50,000 years ago. So the Pleistocene extinctions are the extinctions of large megafaunal like mammoths, giant sloths, saber-toothed cats, and things like that. And there's been a debate over whether hunting or climate change was the main factor that contributed to the Pleistocene extinctions, or whether it was due to a combination of the two. So there's 2 main hypotheses, one being climate change, so warming. At the time there was glacial retreat, because we all know the movie Ice Age with Manny and all those characters. They're talking about the Pleistocene, and there used to be glaciers that extended way farther south into the North America and across the world. And they started retreating, because the Earth goes through glacial, interglacial cycles. And it's thought that that could contribute to the loss of these large megafauna. But another main hypothesis is the overkill hypothesis, which is that humans are the main cause of the extinction of woolly mammoths and whatnot. And it's thought that, humans are overhunting them, and as the humans started expanding their ranges into the Americas, they caused the woolly mammoths to go extinct. So it's most likely a combination of these two hypotheses rather than one or the other. Why was there a megafauna bias? Because during the Pleistocene, only 11 out of 57 mega herbivores, so your mastodons, your woolly mammoths, your large giant sloths and all that, survived to the present. And maybe the reason for that is because megafauna live longer and they have fewer offspring, right? So there's greater parental investment involved in the development of their young when it comes to these megafauna as compared to smaller mammals, which are able to have way more litters way more quickly, and there's much less parental investment into them. Again, and also megafauna are way more attractive targets for humans to hunt. Now, they're easier to find, they're large targets, and provide way more meat and resources per kill. How about the 6th mass extinction? So this is getting back to my question from earlier about what was missing from those 5 great mass extinction lists. And the answer to that is the 6th mass extinction, which is also known as the Holocene extinction or Anthropocene extinction. And that is the ongoing mass extinction event caused by human activity currently. So scientists are calling the current geological epoch or era a mass extinction event. And that's because the current rate of extinction, the current extinction rates of species are estimated to be 1,000 times higher than the background native rate of extinctions. And this is based on our fossil records again. So this is due to, human activities. And here's just a graph showing atmospheric CO2 in the past 800,000 years with ice core data as a proxy for global temperature. So for those that don't know, what we do is we drill these ice cores into Antarctica and Greenland, and we're able to extract data from trapped air bubbles that contain past atmospheres, basically, because based on the ratio of these oxygen isotopes in the trapped air bubbles, you can determine what past atmospheres looked like. And since we know that greenhouse gases are what cause the Earth's atmosphere and to be warmed and to change temperature over time, we can basically use atmospheric carbon dioxide as a proxy for global temperature over the past 800,000 years. And as you can see, this graph shows those glacial interglacial cycles. And if you look at today, the current global carbon dioxide level is significantly higher, almost double what it has been in the past 800,000 years. And that's because humans have been causing the amount of carbon dioxide in the atmosphere to increase dramatically, which is causing modern global warming. And this is a chart that blew my mind. So this is just comparing the current rate of global warming as compared to past global warming rates. And as you can see, the current rate of global warming is on trajectory to be way faster than the rate of global warming for every previous mass extinction event. So even the Paleocene-Eocene, which was our largest mass extinction event of all time, was still almost half the current trajectory of global warming increase. So I think that's very telling for maybe the future of species on Earth. So what's causing the Anthropocene extinction? And the answer to that is humans. So human activities are rapidly altering the climate. 44% of land on Earth is used for agriculture. 75% of land on Earth is no longer considered wild, according to this paper from 2008. Global warming, temperatures are rising faster than many species can adapt. The oceans are acidifying, so more CO2 is dissolving into the ocean, which weakens and dissolves calcium carbonate shelled organisms. So we're definitely going to see a decrease in shelled organism abundance and diversity in the future, unless we do something to stop this increase in global CO2. Sea levels are rising, so as global ice caps are melting, there's more water being input into the ocean, as well as water expands when it's warmer due to thermal expansion. And therefore, if coastlines are going to be flooded, coastal cities would definitely be negatively affected by sea level rise. Invasive species are finding it easier to outcompete prey and are being introduced more often due to humans. And then overexploitation. So we're farming, we're hunting, we're fishing, we're removing species from natural environments at a rate faster than they can be replenished. So yeah, back to the 6th mass extinction. Current extinction rates are as fast as the big 5 extinction rates. While rates are currently as fast as previous big 5 extinctions, the actual species loss is still well below the 75% species threshold to be considered mass extinction. So we still haven't reached quite mass extinction levels in terms of the actual amount of species lost, but the rate is faster than the loss of species has ever been for previous mass extinctions.